Okay, so now we're going to look at like the modulus of complex numbers. So what is the modulus? Well, you need to understand what it actually is in order to do it, right? Because sometimes there's questions asked on the modulus itself, theory questions, right? So if we have our Argand diagram, so it's like our axis and our imaginary numbers are here and our real numbers go across the x-axis. And we plot a point. So for the sake of explaining this, we're going to use z1. So we know that z1 is 5 minus I. So we go to 5 on the real axis, 3, 4, about here we'll say, and minus 1 on the imaginary axis. So we're going to just plot our point somewhere like here. Okay? What modulus actually means is the distance of the point they've given you to the origin. So the distance from this point to the origin. We know that the origin means 0, 0. That will always be your origin in coordinate geometry or in complex numbers on any kind of an axis. Your origin is always 0, 0. So what we've calculated by calculating the modulus when we do it is the distance from the point to the origin. So that's what our modulus is. Right, so it's how do we do it? So your formula for your modulus, so the way they, I suppose, the way you recognise if they're asking for the modulus, they might say the modulus of z1. Then brackets, these two brackets here, they mean modulus. That's what they're looking for. The formula is a formula you will have seen before because you've done the chapter, but it's not in your log table, so you need to know it off by heart. So the square root of a squared plus b squared. So where a is the real number and b is the number in front of the imaginary number. Okay, something that's really important to know is that that is always a plus there regardless. It's always going to be a plus regardless if your b number was negative. You put it's subbing in, so you put your negative b number in brackets if that's the case. So we're going to find the modulus of z1 first. So the modulus of z1 will be the square root of, so we know z1, I'll just write it here so you can see, 5 minus I. We know that minus I, just the same as minus x, would be the same as minus 1x, so minus I is the same as minus 1I. Okay, so square root of a squared, so where a is the real number, so we know 5 is the real number, so we're going to sub in 5 and square it, because we've subbed it in for a, plus goes there regardless, and then b squared, so b is the number in front of the imaginary number, so we have minus 1 is in front of the imaginary. So we're going to have plus minus 1 squared. So we'll get the square root of 25 plus 1, because minus 1 squared will be 1, so square root of 26. So the modulus of z1, or its distance from the origin, is root 26. So we know that that's root 26 there. Okay, and we'll do the same when we do it with z2 this time. So we know that z2 is, from the question, z2 is 4 plus 3i. So let's find the modulus of z2. So we get the square root of the a squared, so which would be 4 squared. So in your 4, put it in brackets, plus b squared, so the number in front of the iota, or the I, which is 3, so we put 3 in a bracket, sugar, and squared. So square root of 4 squared is 16, plus 3 squared is 9, square root 25, so which is 5. So the modulus of z2 is 5. Right, so that's all easy enough, not too bad. You need to know this formula here, that's what's really important, and you need to know, I suppose, what it looks like, how they ask modulus, distance from the origin as well. They're all really, really important things. So what happens if they ask you a bit more complicated of a question? So if they ask us, for instance, say, on which they do on a regular basis, what if they ask you to find the modulus of z1 minus z2? Okay, so it's so important. I can't stress this enough. You do what's inside the brackets first. And then find the modulus of your answer. Okay, and I suppose this makes sense in a way, because if we look back up here, if we look at our formula here that I just have highlighted, a squared plus b squared, where a is the real number and b is the number in front of the imaginary number. If we were to just do it with here, we'd have two real numbers and we'd have two imaginary numbers. So it's too much information. So you need to tidy this up, that you'll only end up with one real number, one imaginary number, and then you find the modulus of it. So so do what's inside first. So right, we know that Z1 was 5 minus iota. So Z1 was equal to 5 minus I, and Z2 was equal to 4 plus 3i from the question. So we'll just use the same question again. Right, so find the modulus of Z1 minus Z2. So as I said, if it's long like that in the centre, do what's in the brackets first and then find the modulus of your answer. So we'll go Z1 minus Z2. So we're going to sub in Z1 minus, and then sub in Z2, so put them in brackets. So that'll be 5 minus I minus 4 minus 3i. And we did this in the previous video, and we got 1 minus 4i. So we know that Z1 minus Z2 is equal to 1 minus 4i. Now we want to find the modulus of that answer. And it makes sense to us that we would do the part in the middle, because now we have a number for A and a number for B, whereas before we had too much going on. Right, so the modulus, so we're going to do the square root of the A squared, which would be 1 squared, plus, it's always plus regardless, and then B squared, so the number in front of the I, which is minus 4 in this case, and we square it. Square root of 1 plus square root of 4 squared, or minus 4 squared, is plus 16. So minus 4 by minus 4 gives us plus 16. Square root of 17, and that's your modulus of Z1 minus Z2.